or there is an extra ticket required. But there we traditionally review use cases, actual projects and designs that have gone into use in the field. And again, the focus here will be on DC coupled designs, some with bidirectional power flows. Many of now have started to include low voltage DC power distributions, such as PoE, USB PD, and fault managed power. And a growing interest is in interconnecting microgrids. And of course, that's where the DC coupling of microgrids internally have the most utility and makes it easier to interconnect them as a, if you will, a functional network of power. At the conclusion of the morning's workshops, those who attend will be invited to take a VIP tour right down on the show floor, and this is before the show opens. So you'll have a chance to see up close and personal and visit some of the OEMs who will be installing their equipment along with Doosan under Doosan supervision, if you will. So you'll get that opportunity. And then in the afternoon, I'll turn it over to Doosan, who's heading up our afternoon workshop event.
Thank you, Brian. So in the afternoon, we're going to have another workshop, and this one is going to focus on how do we design and model hybrid AC and DC microgrid, especially in the DC space, figuring out how do we design microgrids with overcurrent protection. It's kind of a mystery. So we're going to tackle that with industry experts that are going to join us from ABB and help us put this workshop together. So in this workshop, we'll go through actual design of AC/DC microgrids, review the architectures. We'll address how can we actually get these things faster to the market. We will talk about interoperability amongst the components, and we will heavily focus on decision-making strategies on how do you choose your circuit protection. And then afterwards, we will also take a tour of the live DC microgrid, and we'll have all the experts there where you can ask any detailed questions.
Thanks for that, Doosan. Brian, can you start us on a tour of the activities that are going to be focused on microgrids during RE+?
Sure, Daryl, and I was so anxious to talk about this, I interrupted you. But yeah, the main event or the main live indoor microgrid is located at the Grid Edge Theater, and you see that's in Hall A here on main aisles. It's section A61027. So there's a little map, and you see this year's show is quite large with a lot of different venues. So keep in mind that the Grid Edge Theater, if you want to get to see all of this and the presentations and such, we'll talk about in a minute. It's in Hall A, and it's pretty easy to find when you come in the main entrance there. With respect to that, the reason we call it a theater is that it houses presentations for all 3 days of the event. And you can see there's quite well attended sessions there. We'll have industry experts, again, principally focused on the microgrid genre of activities. And you're welcome to come in. This is an event that is a walk-in, so you can walk in from the show floor after maybe you visited the live microgrid, which is directly outside of it. The program there is pretty packed for 3 days. As long as the exhibit hall is open, there'll be pretty much non-stop presentations except for the lunch hour. So take a look at that program. Again, it's in your app and for the show, and you can look at it and decide which of those presentations you might want to attend. But the main thing at the Grid Edge Theater is really the live microgrid. It's a hybrid AC/DC microgrid, and you'll see why in a couple minutes as we go through it. And Daryl mentioned the partners, and here's a partial list of them that are involved in the indoor microgrid. And I'm going to turn this over to Doosan, who can talk a little bit about what we try to do with that live microgrid and what's involved with it.
Yeah, absolutely. So this year we're gonna demonstrate a hybrid AC/DC microgrid just like every year, but we're gonna level it up, right? We're gonna this year demonstrate the in live, in person, the typical operating modes of the microgrids with multi-vendor equipment, what we call. So the microgrid that's going to be at the Grid Edge Theater will be able to get it through the typical operating modes. That's normal operation, grid outage, backup power, and how do you actually power AC loads from a DC bus. So the participants of this year's multi-vendor DC microgrids are going to be Savant, AEG, Block Energy, GridBridge, and this is important to note because with the eMerge Alliance, we always strive to figure out how do we make systems interoperable, and the Grid Edge Theater is the testament that these microgrids can be interoperable and live. So what we're going to have is a residential, what we call a residential hybrid DC microgrid, and the main equipment there is going to be featured from Savant. It's the Savant PS20 appliance. And if you could go back to the previous slide quickly.
Okay.
The Savant system will be able to run a support AC loads of the Grid Edge Theater and support a DC bus. The power is going to be distributed through AEG's power distribution panel, and there's going to be a low-cost microgrid controller that's going to operate this entire thing. So let's go ahead and let's go through the individual components of the microgrid. So this year, AEG is supplying the UL certified power distribution panel. AEG International focuses on creating DC microgrid renewable energy solutions, and their main products are 350 volt DC warehouse lighting and PoE office lighting, along with the DC power distribution panel. Now, why is this so important to showcase, and why is it so important to be part of a DC microgrid? It's because it really shows how you can DC couple various energy sources and loads in a very compact design and offer protection. So this is a fantastic product. Next, Brian, I'm going to let you talk about Block Energy's involvement.
Sure. You know, there, as folks know, we aren't partial to either behind the meter or in front of meter microgrids. And one example, so we include both. And in the same, I'll call it power zone of the demonstration, we will have one that sits on the utility side, and it's done by Block Energy. Typically, the microgrid is a microgrid in the box, if you will, that sits at a resident's home, connects to perhaps photovoltaics that are on the residence, but contains a battery set and power conversion and so on and so forth. And ultimately can typically is supplying AC power into homes because that's how they're currently wired. But in the future is future ready, if you will, to supply DC power as well to either typical loads or maybe EV charging or heat pumps, etc. But the idea behind fitting this on the utility side is to incorporate that into a distribution network, which will be available to be discussed and shown there. And we'll show you that in a second in our 3D community diorama and how this rolls up to what, in essence, we call the grid of grid. So some people have started to call it the Internet with an E, that is, energy network. That's the idea of having the block box there, so you know that there are alternatives for both in front of and behind the meter with regard to microgrids at this level. So next, Dusan, maybe you'll talk a little bit about how we designed or how you designed this microgrid and how others can as well.
Yeah, wonderful. I mean, one of the efforts that the eMerge Alliance makes and Direct Energy Partners is we're trying to figure out how do we reduce the soft costs of design, engineering, and procurement of micro components to make them more accessible. So this year's microgrid has been designed in a new online a DC microgrid configurator called DCID. It's accessible at dcid.app. And really, it features an intuitive design interface. It's kind of a drag and drop solution. Brian, I'm just going to tell you next when to switch slides. So let's go next. In Decide, you can create very content-rich microgrids that are actually functional. So unlike in Visio or PowerPoint, your content-rich designs really come to life, and you can bring them to life further with simulations and other features. Next. Here you will find a curated product catalog, and I'll explain why this is important down the road. But we feel like we have the world's most comprehensive DC product catalog also that you can tie into your designs. So we put products at your fingertips. Next. The program also has harmonized data sheets, so the selection of equipment becomes easy, something you can do within minutes rather than weeks. Next. And of course, when you design your microgrid, you can take advantage turning your single line diagram into powerful simulations like powerful simulations. Next. And if you design your microgrids, you have the opportunity to publish them publicly. Brian, I always say, you always say that the AC rules runs on copy and paste, and that's exactly what we're trying to accomplish with DCID, making sure that people can copy their designs and with real world components, and work on their next version and revision of it for their applications. So let's go next.
Yeah.
So
I was going to say, I can't tell you how many times, by the way, that people will tell us that their project got shot down because the upfront soft costs are just too expensive as compared to somebody doing something in a more traditional power system. So bringing down the soft costs up front vis-a-vis this kind of approach really makes a huge difference.
Well, that's exactly it, right? We believe that a lot of the decisions are made in the ideation phase before you dig into the systems engineering, and there's just so much work to be done there. So with the slide that you have in front of you, this is actually the single line diagram of the grid edge theater that's accessible live for people right now. The URL code is a little bit long, but if you scan the URL code and you put it into your computer, you'll be able to go and look at the single line diagram of the microgrid. And that just kind of shows the power of how we should be treating these designs to help the proliferation and reduce the soft cost.
And then again, people can access that along with just a trial of this whole design scheme by going to decide.app, you said. So that's DCIDE.app. Right?
Yeah,
that's
exactly.
Pretty simple.
It's really simple, and if you click on designs, this design will come up. It's free and it's easy to access. So I just want to point out very quickly on this single line diagram the role of the Savant battery. So every microgrid typically has the heart of the microgrid, and this year we have chosen the Savant battery for that, because it's a very compact, versatile, all-in-one, battery system with an inverter that can support both AC loads and DC loads. And as we transition to a DC world, there's going to be this transition phase where you have to support both AC loads as well. So this particular unit will be able to power the grid edge theater AC loads, whether the utility power is there or not, which means it can grid form. And it will be able to provide a stable DC output voltage, which we're going to use 350 volts for that, to the distribution panel that you've seen. And all this can be seen on the single line diagram. And from there, we're going to power loads, and we're going to go through the loads in a second. But this is going to show the how we can create actually DC network to support loads. So we're going to have direct loads powered, like air conditioning systems from various vendors, but we will also be powering a fault managed power system from Sinclair Digital to show how you can add various devices to further transmit power without conduits, I guess. So next.
Okay, maybe I will explain this one because, again, this is sort of more of an outside the meter version. But one of the companies that's joining us in demonstrating this year is GridBridge. It's an Aramco company, and they make power electronic transformers, if you will. And these are transformers that can not only support the AC side of a system, but also potentially the DC side as well. With power electronics, the advantage over, say, coil transformers is that they have that versatility of building in power conversion, not only of voltage, but also of mode or form. So that is significant. We have a little demonstration unit that you'll see on a utility pole right at the corner of the grid edge theater, connected to the overhead simulated utility lines, if you will. You'll see those stretch across the grid edge theater. But there'll be a GridBridge people at the show to explain the full array of power electronic transformers, some of which sit further back in the distribution system, all the way back to, in some cases, a substation. So there's plenty of interest by many about the use of DC and storage and such in the distribution system at further away from the point of use. So let's see. You already explained Savant, but did you have any other thoughts on that before we move?
Yeah. I mean, let me just add a couple more thoughts to the Savant system. So the battery also the battery system features a modular battery system, so which is fantastic for serviceability. You can see that in a picture. I think there's like 8 50-volt batteries that make up a 400-volt system, and yeah. Lastly, I would say it can support both hybrid AC loads, DC loads, and take solar panels in directly. So this is definitely going to be the star of the show.
Okay, and to show how an individual microgrid, particularly a DC coupled microgrid, fits into the bigger scenario, or what some people would call the end game. You know, what's the end game? Where are we going with all this? And that is to essentially transform the grid edge into a network, a bidirectional network of power systems. And by making the majority of that, particularly the newer installations, non-synchronous or DC, makes it easier then to form these types of networks that are both bidirectional and avoid peak loads and things like that because of the shared storage resource, et cetera. So we're going to be showing we can't bring a community into the convention center, although we're getting close to, I think, doing that in a similar way. As you'll see when you get there, it's going to look like a mini city of sorts. But we do have this 3D diorama. It's interactive, meaning that it will show depth through various conditions in a community, and you'll see how the grid in this case, again, bidirectional and at times under DC distribution loops, how it reacts to various events in the community. So make sure you stop by and see that on your way past as well. As I mentioned, the end game, the way at least we see it, is just like the PC was the beginning of the internet, we believe that the microgrid, or as some people would even call it, the nanogrid at an individual building or premise, is the beginning of the internet, or the grid of grids. So more and more, I think, as the months and years go on here, you'll hear more and more about the idea of mesh networks and a grid of grids. Not only in a regional grid in the distribution, but potentially with HVDC, which we're not featuring at this show yet, but with HVDC, potentially you'll see a worldwide or global grid as well, where power is shared from continent to continent. That's already happening a little bit, so it's a little bit advanced, but we'll be talking about that more and more, and we wanted to preview it here. So the other half of the Yeah, go ahead, Darrell.
Brian, if I can interject, as we're talking about the grid of grids, how would something like this, or how would a local power utility interact with this type of network?
Well, there are several choices, depending upon what kind of a utility is. Some of them will operate as a co-op or community type nonprofit or what have you, and they might approach it where the essentially this grid is a subcomponent, if you will, of the more commercial grid or the network that most grids tie into. Public utilities can deploy, for example, and you saw the Block Energy Block Box approach by putting these nanogrids, if you will, at buildings and then connecting them together in the distribution system really facilitates the utility to a great degree, and at the same time offers the kind of resiliency that everybody is looking for at the premise level. The way it helps the utility in particular is that it can help do load shaping, it can provide VARs, it can be doing frequency support, it can be doing a lot of things that individual microgrids or microgrids, if you will, behind the meter don't necessarily get to enjoy, at least in today's regulatory environment. We do see this kind of regulatory environment for all of this as to where the lines are drawn. Today we talk about in front of the meter, behind the meter. But I think as time goes on, that line or that definition of the way of describing the distribution and use of power is going to become more and more fuzzy, if you will. And you'll see a lot more business models, both used by utilities as well as by third parties and private owners as well. So it's definitely an industry in transition, as the and other people would describe it as an industry and full of disruption. In any case, whether it's transition or disruption, the word opportunity hangs on both ends of that.
Yeah, excellent point. And as we're moving forward here, talking about DC load zones, what kind of unique loads and subsystem power distribution will a live microgrid support?
Well, first of all, I think native DC, particularly at higher power levels, is fairly appropriate, and you'll see demonstrated, for example, in this, and we'll talk about it in a second, electric heat pumps. The whole transition away from fossil fuel, HVAC, and water heating, and some of the big appliances in a home, including electric vehicle. I mean, electric vehicle charging alone is going to add significant load, and would prefer to use DC as opposed to AC to reduce the conversion losses and such. So the big loads, native DC is typical. Some of the other loads that are maybe more touch sensitive, as some people would call it, can use fault managed power, which is pretty sizable power, but in a touch safe mode. Or go to things like PoE, where you get down to 48 volt distribution, or even lower distributions, 24 and under, with USB PD, as we're seeing come in from the computing world and the Internet of Things environment. So all of those things, today's technology, it's been said that the actual use of electricity in buildings and such today is probably in the realm of 80% to 90% natively DC, which means that all the power that's produced and delivered at AC is getting at some point converted, and in some cases converted multiple times back and forth because of the desire to use storage and other techniques where you do double and triple conversions on the way to the point of use. So we're seeing pretty substantial efficiencies, but even more than that, I believe that the ability to articulate a system, and what does that mean? To load shape, to only use as much power as you need. It's like when dimming first came in to the lighting industry, using less light when you don't need it, et cetera, et cetera. and that's the kind of thing that DC can do is power an appliance with a brushless DC motor where you only use as much power as you need at any given point in time. So you don't run on off, for example, with a compressor and an air conditioner. You run it as a variable speed device. And by using a DC brushless motor, you get a more constant torque. So you can carry pretty heavy turn loads in a system with a DC brushless motor that the AC motors, even with a variable speed control, aren't able to do. I know it's a long answer to your question, but there's a lot to it.
Let me just add.
You wanted to chime in there, correct?
Yeah. Just to add on kind of what Brian said, it's funny, like, anything that has a microchip runs on DC internally, and in this DC load, the manufacturers that are supplying the HVAC systems and the EV chargers, they are regulated by certain standards, and the efficiency standards that these equipment manufacturers are regulated by, are driving these manufacturers to make equipment more and more to be powered internally from DC power effectively. So most of the equipment that you will see at the DC load zone and in the future coming out from various manufacturers is actually dual power. You can natively now start feeding DC into an approved DC voltage into the equipment, so they're actually DC ready, and I think that's a very exciting future for DC coupled equipment.
We've been talking more and more at eMERGE about creating a standard for dual input, so that appliance manufacturers, equipment manufacturers know that instead of putting in a power supply that's either married to AC or DC, which means then two SKUs, if you will, to on equivalent equipment, it's better to put in a power supply that can be hooked up to either AC or DC. Of course, when it's hooked up to DC, it's going to be more efficient generally, and be more easily articulated in a smarter, intelligent system that manages load. But generally speaking, dual input is, I think, the next step in that evolution. So some of the equipment that we're going to demonstrate there, again, these are examples. There's a lot of equipment out there now that is starting to run or can be run on DC. We have two different charging systems, vehicle charging systems. We have the mini split, which is the HVAC or the heat pump, if you will. The idea there is originally that many of the people had the concept of just connecting those heat pumps directly to solar, which is fine, and you can do that. But better yet is to connect it into the DC microgrid, and then it becomes available to use the power however it's being generated by and managed by the microgrid. Similarly, we have a large-scale EV charger shown at the grid edge to demonstrate, with very high levels of DC availability, that you would get very efficient charging, probably not at your home, but in light commercial or multi-dwelling residential settings. And then the Intelligent, company called Intelligent, has a DC charger. Again, this can run directly off of PV, but better yet is to run it off the DC microgrid. So a lot of things that have been and will be developed for direct solar powering, but then run the risk of not necessarily having solar all the time, are probably better connected to the microgrid, which can manage the power 24/7. So we will be demonstrating a couple different forms of DC power distribution through our friends at Sinclair Digital. They will be demonstrating some fault managed power, and that's a higher voltage, but digitized, if you will, digital power, which is touch safe. I believe they're in the 300 to 400 volt range. And also the PoE, the latest generation PoE, which is running in excess of 100 watts these days. and still climbing. So that's a 48 volt, generally 48 volt system, but carries data along the same cable. So those are things that we'll be demonstrating to show that the integration of DC with other distribution systems is advancing as well. And we'll have a train unit, one of the latest train units, which uses DC inside, if you will, architecture with brushless DC motors and electronic control. You see the control board here. So this is a variable speed, if you will, brushless DC motor that minimizes the amount of power that your HVAC needs to draw if you go to an electric heat pump, which more and more is going to be the case. So a lot of things will be demonstrated there. Whoops. But as you said, Daryl, there's a kind of a story behind why we would want to do DC coupled microgrids. There are, of course, the alternate architecture AC coupled, which actually, in many respects, you would say predated people starting to do DC. Except if you go back to just around about 20 years after the turn of the century, most of the rural electric systems that were used on farms were all DC. But then they faded away in favor of AC because of long distance transmission. But then later on, DC now has made the comeback based on power electronics. So we have a whole wall the outside of the theater that's dedicated to telling the story of what DC coupled microgrids are all about. And each of the infographics along this wall are tied to AV presentations that you can queue up either at the show or later on, just recording the QR codes and experience this later on. But it will go through the architecture of what is meant by DC coupled microgrids, what kind of equipment is involved, how to design it, some of the things that Dusan will be talking about in the workshops and on the show floor. It'll talk about what features are offered, what are unique features, if you will, that are offered from a DC coupled microgrid, and then generally, what is the value proposition associated with DC coupled microgrids? So that's one wall of the theater. The other wall of the theater represents a lot of the use cases, at least the most obvious use cases. There's a discussion, as we talked about, the sort of linked community type microgrid, multi-tier microgrid. We have their residential microgrid, commercial and industrial microgrids are represented. I believe we have utility microgrid and there's, I think one other, no, I think I had them all. Again, there's AV presentations that are linked to all these infographics. So if you come to the show and just want to queue up one of the AV presentations, and you'll learn a lot about those use cases, or you can come to the workshop on Monday. Either way. So maybe we should take a walk outside of the main convention center. I said we were in Hall A with the Grid Edge Theater. But the outside microgrid is located in what's called the Marriott Outdoor Pavilion. Hard to miss because it's right next to the Marriott Hotel, as you might suspect. But in that parking lot area right next to the hotel, among other displays and things out there, we will have an outdoor microgrid which is dedicated to powering an EV charging station. And this is just a single charger, but you can imagine by scaling this that you could make it a more commercial installation as well. But we wanted to show people, what it looks like, as a standalone, if you will, system. In that system, we have, again, we're using a sun action tracker PV array. And as you know, the tracking arrays tend to generate more power because they are more efficient in gathering the light versus a static rooftop or other type of display or array. So that's where we'll be getting the energy to do the charging from. And that will go into a block box, which would be typical of many different types of, whether it's be in front of, behind the meter type of systems, like the Savant or the block energy box, if it's done by the utility, whatever. And that'll be converting the PV and storing it and so on and so forth, combining it with AC power if it were available. In this case, it's not, so this is kind of an islanded mode dedicated microgrid. And then finally, we'll be using the intelligent charger again because it's ideally suited for, particularly single vehicle charging, although you can array these as well into multi-station charging stations. So that'll give people an experience that they haven't already seen, the guts, if you will, of what a EV charging station might entail, whether it's done commercially or at your home, and that'll be outdoors again. And just for fun, Doosan has always told me that the design system called Decide, as we talked about before, is really, really, really easy to use. Cut and paste. In my life, doing a lot of these presentations is all about cut and paste, right? So I downloaded the Decide, or I linked into the Decide app, decide.app, and started playing with it and actually designed the microgrid for the outdoor demonstration. And of course, me not being a licensed engineer, I ran this past the licensed engineers as a typical one line, and they agreed that it fairly represented, particularly at the conceptual level. I didn't do power flow analysis, but at the conceptual level, it represented a fairly accurate representation. That again, and I was kind of showing it, if you will consider RE Plus, our event management company, showing them what we were going to do. So I was kind of testing it out if they were the customer, showing them how my Decide tool designed microgrid would show up at their show. So just to give you an example, that when Doosan was saying that it's an easy kind of cut and paste, very intuitive design thing, and much better than PowerPoint, I did this whole drawing in Decide and not PowerPoint. Even with all the pictures and everything, it's pretty cool. So any comments, Doosan? Am I okay? Did I do anything wrong?
No, wonderful. I'm happy to hear that. I think that's a testament for the ease of use, and I'm happy you were able to pick it up and run with it.
Yeah. So I personally kind of endorse the approach of going to this kind of a design system. It's really nice. I'd like to, Daryl, if I can, just talk. You mentioned a few things about the eMERGE Alliance at the beginning of the webinar, but I wanted to very quickly just talk about what eMERGE really does besides demonstrations at RE Plus trade shows and regional shows. So we're about creating these Vanguard standards. And again, what's a Vanguard standard? Well, a Vanguard is anything that's in front of the action. It happens before everything else follows. So with a lot of standards in today's world, people wait until there's what I'll call commercial inertia, and you maybe have 10% of the market moves to a particular new technology, and then everybody scrambles after that to figure out how to untangle the spaghetti mess that was created in the first 10% to make it practical and standardized and economical and so on. So the idea that eMERGE had, knowing that the power electronics world and the renewable energy world is moving at a breakneck rate and speed of development, and pardon the pun, but it's emerging so rapidly that it doesn't make sense to wait until there's a lot of equipment all slightly different and not interoperable out in the field and then try to sort that out. That might have worked for computers with different connectors and things like that, maybe cell phones. But when you get into big systems and infrastructure like power systems, that's not a good way to go. So we try to get ahead of the curve. We've been working on DC technology since 2008 when eMERGE was formed. And all of the work that we do on standards is really anticipatory or try to lead the market. And now necessarily what that also means is that the standards tend to be minimalistic, which is good for people who want to put their own innovations into systems and differentiate themselves in the marketplace and offer things that, not everybody has. So our standards tend to be fairly minimalistic in a sense that they're just calling out primary voltages and really critical things, critical to power flows and safety and the physics of power movement. We don't overly prescribe everything that a microgrid should do, or how it should work, or what software to use, or any of that kind of stuff. We're really primarily looking at the basic architecture.
And Brian,
so that's
if I
what.
interject quickly, you mentioned safety, and I know that's always at the top of everyone's mind. But I'm wondering, as your group develops these standards, are you talking to any regulatory agencies? Are they giving you input?
Yes, well, we, of course, our members normally already have established some connections with whether it's listing agencies like UL and CE and so on, but also the regulatory people, the utilities that are a part of eMERGE are involved with utilities and with the regulatory bodies. We have had pretty direct communications with a few of the regulatory bodies in the public domain, which are public utility commissions, which is California and Chicago are the two big ones that we've been pretty significantly involved in, but indirectly involved with others, like in New York and other states and other public utilities that have started to move in consideration of new regulatory guidelines and codes. Same thing applies to the safety side with NFPA, the folks who write the National Electrical Code. But that's really when we talk domestic. When you talk international, then we broaden that out and say, well, there's the IEEE, there's the IEC, there's organizations, in particular in DC, an organization that we're having very close discussions with in terms of harmonization of standards, is an organization called Current OS. And there are others in different countries. The Indian standards organization in India, very active, in China, and so on and so forth. So we have pretty much an open tent approach to this, where we say, look, we're going to bring the group of experts together and create the standards, but those standards we want to share with everybody else. So any of these other organizations can take our standards. We wrote the basic standard for example, for DC revenue grade metering. We immediately handed off that to NEMA, who is the secretariat for the ANSI C12 committee that writes the standards for power meters, the kind of power meter that's on your home, or maybe in the car charger. So we want to just be the organization that gets in front of that curve, does the early kind of basic work, hand it off to other organizations so that they can further detail it out if they want to for their own uses. Right now, we also have a collaborative effort going with Bixby, who's working on, as you may know, the smart buildings and so on. So our idea is to network with these other organizations as opposed to try to develop something that competes with what others are trying to do. In particular on safety, by the way, we subordinate anything we put into our standards or our recommendations to the authorities having jurisdiction. So if the authorities having jurisdiction says you shall not do this, that, or the other thing, then we're not going to write a standard that challenges that until we can convince them to change their standard. And we've done that in the past. We have worked with NFPA, for example, to change some things in the National Electrical Code that made it easier to incorporate DC type architecture. But until we do that, our standard will not prescribe anything that violates codes or authorities having jurisdiction, if that makes sense.
Yeah, thanks for that, Brian. And let's just run through some of these standards, starting with this one, the DC and hybrid AC/DC microgrid standard, if you can just talk about that for a little bit.
Sure. One of our early standards efforts was really focused just on DC and not the notion of you need to be hybrid. and then we realized that the real world it's going to be for sure, maybe forever, a blend of both AC and DC requirements. So we're not going to throw the grid away, and we're not going to throw all the appliances away and start over again. We're going to blend those into the architecture over time, and maybe as time goes on, you'll see the pendulum swing more and more toward the DC side. But in the meantime, we can ill afford to to compromise or undercut the value of traditional AC power. So we're working to incorporate it and support it wherever possible in the standard. So we did write a new standard, just issued late last year, called the DC and Hybrid AC/DC Microgrid Standard. Again, this is available for free. Go to our website. You can sign up for it there under the standards link and get a copy of that. The other standard that's very new from us is what we call the Power Device Interoperability Data Model Standard. What this is just a framework of how to construct a data model in JavaScript object notation, or some people would call JSON, right? Which can be imported into most other design software as information, if you will. And it basically is attempting to describe the critical inputs and outputs to electrical devices that allows you to design those devices into a system that operates reasonably and safely. So that's what the whole idea of this standard is. It's not a compliance standard, or you don't have to meet any compliance regulations, any of that kind of stuff. You need to do that anyway if you're going to sell product in the open market. This is simply to create a format so that people have the ease of importing the information about OEM equipment into state-of-the-art design tools. And I will say that Decide is an example of how that's done, and but I'm sure others will want to do similar things as well. So that's the standard. Did you want to add anything, Dusan, about that? I know that you're, I'll give you the plug that, Dusan's our president, but he's also the CEO of Direct Energy Partners. And thanks to Direct Energy Partners for the basic idea as they work through the idea of trying to design DC microgrids, realizing that this effort up front, the soft effort of trying to design and conceptualize microgrids, is a really a difficult thing to do without the right tools. So go ahead, Dusan. You can describe a little bit more about this.
Yeah, absolutely. I mean, one of the biggest motivations behind this interoperability data model was to, again, reduce the soft cost of adopting real-world equipment in a microgrid design within computers. So I would say I think this is the first time that a standard is going to be accompanied by a JSON library of equipment. And, we realized that it was very important for manufacturers to not just publish data sheet, but publish data sheet of equipment with the correct attributes. And those attributes, right now are just a mess, right? You don't always get the right information that you need. And so this interoperability data model, the standard, is focusing on the electrical, mechanical, and controls interfaces that you really need to assess if an equipment from vendor A will work with vendor B. And it's not just across individual product lines, let's say converters, but also across categories. What makes something interoperable across converters and batteries, or converters and circuit breakers? How do you do that? And so with the efforts of the eMERGE Alliance, we want to work with the manufacturers to develop this JSON data model, and not just publish a standard, but also publish it in electronic format for everybody to consume. And hopefully this way we increase the adoption of these of the equipment in microgrid design tools. And Brian, I'd say Decide is the first one to take advantage of this. And the way it can be seen today, it can be seen in our harmonized data sheet. Today, if you go to decide.app/components, you can browse a catalog of DC equipment with this harmonized data sheet that's powered by these JSON data models. that are being open for everybody to use, really. And so that's really powerful. And I would encourage manufacturers to scan the QR code for not just viewing the product catalog, but also register their products. And this will also help, getting involvement and participation within the eMERGE Alliance. And we're always looking for active members to help us further develop these interoperable data models. What you see today is a starting point, but microgrids are so complex that this will continuously keep evolving. And so we need manufacturers' input.
Yeah, and I like to think of ourselves, a lot of people say, well, you're a standards organization, so you must make money from selling standards and all that kind of stuff. And we don't. We, as I just mentioned, we give away standards for free. We're really about accelerating the market. We're here for our members to accelerate their opportunity to create a market. So I like to think of eMERGE as more a market development, open source group that just wants to help develop this market and its ecosystem as quickly as possible for hopefully all the right reasons, for all of the reasons of resiliency and environmental impact and so on and so forth that we all talk about, and even national defense. So we want to do that without being a burden on OEMs. And I think by having OEMs put their products in this kind of a catalog, if you will, and making them readily accessible to designers and potential users, they're going to greatly improve their customer experience. People will find it easier to find their products and to understand how they can be used in microgrid design. So we strongly recommend it. We'll have probably some testimonials from some of the existing companies that have already registered their products and what it's done for their customer experience. But I think the OEMs will see that it's a really advisable thing. So if you want to register your products and get them listed so that people can have easier access to designing them into their projects and stuff, stop by and see us again at the Grid Edge Theater at the booth, and one of the eMERGE or other eMERGE members will explain how to go ahead and register your product. Or you can just go to the Decide app and it'll be also explained there. You can hit the right buttons. I mentioned, Daryl, that we did have other standards, some earlier standards. We originally had some of the occupied space standard, which was technically like a nanogrid, but only the indoor occupied space we were building and not the entire enterprise. And we had a dedicated standard, and still do, I think it's in its third revision, for data centers and telephony central office. They're a fairly specific use case, although many of the elements in those early standards are also carried through to even the latest standard. And of course, the ANSI standard, the C12 standard for DC metering. So again, Daryl, we don't have much more to say other than that we want to encourage people to become a member of eMERGE and help us move this market better and faster to a good solution. So if you're interested, stop by and see us or go to our website and think about becoming a member. A lot of companies have recently joined. We've had a fairly nice uptick in membership, so think about joining. And with that, I'll turn it over to you, Daryl and Tricia, if there are any questions that have come in.
No questions.
Okay,
Okay,
so again,
well,
I would encourage everyone to visit the Grid Edge Theater. And if you're an OEM, certainly register. Talk to Brian and Dusan and other folks with eMERGE Alliance to learn more about everything that that group is doing. And I think for all of us, we look forward to seeing as many of you as possible at RE Plus in Anaheim next month. And Trish, I'll turn that back to you to close.
Thank you, everybody.
Trish mentioned, you mentioned that a recorded version of this will be available at the RE Plus website for anybody that didn't get to listen to the whole thing or want to go back and review any of the material.
Yep, it'll be on our website. That's re-plus.events by the end of the day today.
Okay. And you see the email addresses there. If you have any question, want to talk to one of us directly, please drop us a line and we'll try to respond to you as soon as we can. Thanks. Thank you, everybody.
you.
Have a great day.
Thanks, everyone.
Thank you. Take care.
Recording.